Hey there, it's Miss B, and today's video we're looking at the Unit 2 Lesson 9 and the Lesson 11 cumulative practice problems. So this first question is about a kite. So let's look at this kite. A kite is a type of quadrilateral. It has two sides next to each other that are congruent, and then the other two sides are also congruent. So given kite WXYZ, so they're giving us this one right here down below, they want us to show, aka prove, that at least one of the diagonals of the kite decomposes it into two congruent triangles. And decompose, right, normally means to break down. If we're talking about biological material, same thing here. It's going to break this down into two separate triangles. Now, the line I just drew, that's the line we're going to use, this one here. The other diagonal would be this one here, and we can tell that those triangles are definitely not the same shape based on the diagram, but we can also tell because of the congruence marks. So it would make two isosceles triangles because the one on the left here would have just the single congruence marks where both sides are the same, and the one on the right would have the double congruence marks, meaning that those sides are the same. We want them to have sides congruent to each other, so they each need to have one of each in order for us to start proving this congruent. Okay, so based on that, let's start writing some explanations here. We're going to state a couple things that they give us just based on these markings. So I can say segment WX is congruent to segment WZ, because they gave me that. I can also state, I'm going to say YX, because I want to start at the common point. So I'm going to say segment YX, is congruent to YZ in the given kite. Now we can say draw diagonal WY. So you don't have to tell this, but I like to include it because I want whoever's reading my proof to see, like, oh yeah, hey, that's the one I'm using. I'm going to say this one here is congruent to itself, and then that's going to be our third piece of information that we need in order to prove this congruent. So we can now say segment WY is congruent to segment WY. Now, since this wasn't just given to us, we actually have to explain why. Because because all segments are congruent to themselves. This is the reflexive property, by the way. Not reflective, so it's not like reflection. It's reflexive with an X instead of the CT. So the reflexive property is basically how we can say that a segment is congruent to itself without having to write the whole sentence out. So now that we have the three pieces, we can now make a statement. Oops, that's an eraser. We can make a statement about the triangles. We can say triangle. I'll say triangle X, Y, W is congruent to, and since I started at X, that corresponds with the Z. So this is going to be triangle Z, Y, W, by side, 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 triangle congruence. And you could just say side, 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 but technically it's the side, side, side triangle congruence theorem, so we're going to write that. Okay, so that's actually all we need for this one. We're showing that it decomposes it into two congruent triangles by saying, hey, look, we've made two congruent triangles. So we can say, I guess a statement underneath here is important for that. So therefore, at least one diagonal of the kite decomposes it into two congruent triangles. It's always important to answer the question, so I would have been incorrect if I just left it at that. So I guess that's why we need to write a sentence there at the end. If they're asking me to show something, I can't just assume they'll make the logical step there. Okay, so on to question 2. Mai has proven that triangle WYZ is congruent to WYX using side, side, side. So this looks kind of just like what we did. Why can she now conclude that diagonal WY bisects angles ZWX and ZYX? So if she's proved this by side, 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 she's saying that that side there in the middle is congruent. They're asking why she's allowed to say that the diagonal bisects these two angles here. And that comes from her congruence statement and the order in which we actually prove these congruent. Because WYZ is congruent to WYX, it means that our corresponding angles are here at the bottom and then here at the top. So that's the basis of this, is CPCTC, but it just happens that that's where those two line up. So I'm going to put this part in red. I'm going to say this angle and this angle, and then this one and this one. So we can say angle ZWY. So I'm starting with the ones at the top, is congruent to angle XWY by CPCTC, which is corresponding parts of congruent triangles are congruent. So we're saying, hey, those parts correspond, so they have to be the same. We can also say that about, the angles at the bottom. So angle ZYW, which is our angle at the bottom on the left, that's congruent to angle XYW, which is the angle at the bottom on the right, again by CPCTC, because those pieces correspond. And basically, because now we have angles right next to each other being congruent, that means that WY has to be the angle bisector. So we can say, since the angles are congruent, WY or segment WY must be the angle bisector. which that's its definition, is that it would split those two angles into two equal pieces. That is what it means to bisect an angle. So let's move to question 3. This again gives us a kite. It's WXYZ. But now they're going to actually give us some angle measurements and ask us to find our other ones. So it says angle WXY is a measure of 133, and angle ZWX has a measure of 60, and we want to find ZYW. So let's look at these closer. That says this whole angle here is 133. Oh no, oops, I'm labeling the wrong one. That one has the measure of 60 degrees. WXY. WXY is this one here. This is 133. And they want us to find ZYW, which is this one down here in the corner. Okay. Now, based on some things that I know, like corresponding parts of congruent triangles are congruent, we just proved two things: that kite, as long as that diagonal cuts down the middle, is going to have two congruent triangles by side, 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 and that same diagonal is going to be the angle bisector of these pieces. So those two previous questions actually play an important part in this, because that means my 60 can get cut in half and be 30 and 30. It also means this 133 is going to correspond over here and also be 133. And the last piece of information I'm going to use is that a whole triangle adds up to 180 degrees. So we can say 30 plus 133 plus our red angle here. So angle, and this was ZYW. I can say that is 180 degrees. I'm going to subtract both of those things here. And if we subtract 133 and 30 from 180, that would mean that angle, or the measure of angle, sorry, that's slightly incorrect. I didn't put the measure there. When we're referring to an angle's specific degree measurement, we're technically supposed to put an M in front of our angle symbol. So the measurement of angle ZYW, if we subtract from both sides, though 30 and the 133, we would have 17 degrees. There we go. And that is question 3. So showing my work here, because I am supposed to show all of my work, was labeling the big angles and then sort of labeling what I know from there. I don't have to actually put CPCTC on that. Or like state reasons, I can just show those pieces. Let's keep going. We're going to skip question 4, and we're going to actually do question 5. So question 5 here from this assignment is asking us what triangle congruence theorem would prove that triangle ABD is congruent to triangle CDB, and make sure to justify how you know it will work. We can use words or mark on the diagram. I love marking on my diagrams because that makes the most sense to me, and then I like to write it in words. So I'm generally going to follow that process. So they're giving us here, important to note, they're giving us that DC is parallel to AB. That is the little arrows there that I'm highlighting in yellow. They also want to know ABD. So ABD is this triangle here. I'm going to shade it in. They want to know that this one is congruent to the other side. So I just like to label things. I'm going to do this so that I know which ones I'm talking about. Normally, there might be a more complicated diagram, and so highlighting is important, but I still like to be consistent. So CDB is that one there. Okay. Now, let's actually look at our diagram and what we might know. Because before I actually get started with what pieces of information I need, I just like to mark everything that I know is congruent. And the first thing I see here is that this has a shared side in the middle, so I'm going to make that a nice straight line. So I know that side can be congruent to itself. BD is going to be congruent to BD. Since I have parallels, that gives me the big hint that I can use probably some alternate interior angles. So I know that in order to be an alternate interior angle, my angle has to touch my parallel lines and the transversal. So that means I would have to have this angle here and this angle here. So those are the ones I'm going to mark. I'm going to say this angle is congruent to this one, and I know that by alternate interior. Let's see. I have right angles here, which are going to tell me, all right angles are congruent to each other. So this could be angle, side. Um, The other way we could do this is really finding our third angle here, which is these ones. Because we know all right angles are congruent, or basically because we know we have two angles congruent, we can say that the third one is, because all triangles have to add up to 180. So whenever you have two triangle angles set up to be congruent, by the sum theorem, triangle angle sum theorem, you'll know that the third one is going to be equal as well. And I don't really like to identify angle, side as much, because that one can be a little confusing. But now I do have angle, side, angle. So I have this side here trapped between those two. I couldn't say these ones at first because I didn't have that, like the sides on the left and the right were parallel. So let's actually kind of put this into words and use words to describe what we said. So I can say segment DB is congruent to segment DB. And I'm going to call this, I'm just going to say reflexive property. Because that's shorter than me writing out every segment is congruent to itself. And then the next thing that we talked about was our alternate interior angles. So I'm going to say those angles. So that was angle BDC. It's going to be congruent to angle BDC would be DBA. And this is by the alternate interior angle theorem. Then we said we identified the right angles, but we're not going to use them. We're going to use the triangle angle sum theorem in order to say that my angles with two congruence marks are congruent to each other. So let's say that was angle ADB. It's going to be congruent to angle CBD. And we can say by triangle angle sum theorem. And yeah, so I'm actually going to use a very short form of therefore, which is 3 dots in a triangle pattern. This is the shorthand for saying therefore. So I can say therefore triangle ABD is congruent to triangle CDB by, and this is now using angle side angle. So I'm just going to make a little note on here. This little guy means therefore. And that's because I know that some people watch these videos without sound on, and I don't blame them. So that means therefore. Okay, question 6. Oh man, this assignment is kind of long, but you know what? The good thing is the assignment 11 or lesson 11's questions, we only have 3. So for this one, it's just finding an angle measure. So the proof stuff I feel like is longer. That's why I'm longer winded on that. So triangles ACD and BCD are isosceles. Okay, so ACD, that's this big outer triangle, and BCD is the inner one. DBC has a measure of 84. So I'm going to write that in where I see it. It is right here, 84. Okay. Then angle BDA has a measure of 24. So BDA has 24. So that's right in that corner. And then they want us to find the measure of BAC. They want us to find this angle measure right here. BAC. Okay. All right. And then they gave us a congruent statements based on this triangle. So the AD is congruent to AC and BD is congruent to BC. But it's already marked here. So let's get to work. All right. Okay. Well, based on this, I can start by finding some of my angles down at the bottom. So I know that every triangle adds to 180. So that means this triangle is going to add to 180. So I can take 180 and subtract 84. And I know that then I can cut that in half, and that'll tell me what each of these corners are. So that's what I am going to start with. So I am doing 180, and I'm going to subtract 84. That's going to give me 96. And 96, when we divide that by 2, should be 48. I'm going to check myself on that real fast anyways, because I don't always trust myself. Yeah, half of 90 is 45, and then half of 6 is 3. 45 and 3 is 48. So it's going to be 48, which means I know these are then going to be 48 degrees each. But why do I need that? Well, that's going to tell me now this whole angle right here. So I'm sorry, this arithmetic's kind of not in order, but I'm going to do the 24 plus the 48. And this would be 11, 72. 72. So I have a couple different paths from here. I could have, yeah, the path I'm going to take from here. Okay, I see it. So if I know this angle, that means I know this whole angle too, because the large triangle is isosceles. So using some arithmetic, I can find this whole thing, and then I want to find that and then divide it by 2 to just get one little piece. Okay, So what I know based on my big triangle is that I should have 72 and 72 as my base angles plus, what should I name this? We'll call this angle DAC because that's the big one here at the top, angle DAC. And that's going to be 180. So if I take 180 and I subtract 180 minus 72 and then minus 72, that's going to give me 36. So I could say the measure of angle DAC is 36. But now I need to divide that by 2, and that's going to give me just BAC. So dividing that by 2 is going to give me 18. So then I can say the measure of angle BAC is 18 degrees. And there we go. So seems a little bit disorganized, but hopefully my labels make a bit of sense. The purple is what I was given originally, the red's what I was trying to find, and the blue pieces are what I found altogether. All right, question 7. Okay, reflect, I zoomed in a little too much. Reflect right triangle ABC across line AB. Classify triangle CAC prime according to its side lengths and explain how you know. Okay, so let's reflect across. I'm going to draw this in red just so it stands out a little bit more. If we're reflecting across, this is my line of symmetry right here. So that means if that's a right angle, I'm going to kind of have something a bit like this. Sorry, I was turning my turning my tablet to see if it was kind of the same shape. Might be a little longer. I just didn't really want to run into where it says Unit 2, Lesson 1 down here. Oh, no. You know what? I did that wrong because it says AB, and here I am reflecting it across BC. Goodness me. Okay, I was like, why are they not giving me enough space here? Because, silly Miss B, you're supposed to reflect it across over here. That's what happens when you don't read closely. Okay, now that I've reflected it across, we want to label this part C prime because A and B don't move. And then we want to classify triangle CAC prime. Now, we know that reflections are rigid transformations and they preserve side length. So we know this side is going to be congruent to this side. And the bottom side of the triangle isn't going to be congruent to anything else that we know of. So this is going to be isosceles. And that is because reflection preserves side length so AC is congruent to AC prime. And there we go. So at least 2 have to be congruent. It might be equilateral, but we don't know that for sure. So the only thing we can do is say this. Now that is it for the lesson 9 questions, but there's also another page. We're just going to do questions 1, 2, and 3 from lesson 11. So let's look at question 1 here. We have, which of the following criteria will always prove triangles congruent? And we want to select all that apply. Okay, so 3 congruent angles will not always work. So we're not going to select that one, but 3 congruent sides will. This is side, side, side. Corresponding congruent side angle side. yes, that will work. Corresponding congruent side-side angle, on the other hand, is not always going to work. And I know that they're including corresponding congruent, but we're really just looking like here at SAS. And this one would be SSA, and SSA does not always work. And then this one here, angle side angle side angle will always work. So you should have B, C, and E. Now, question 2, we have some measurements for triangle ABC and XYZ. So we have angle ABC and XYZ are both 30 degrees. Then we have BC and YZ both measure 6. And then CA and ZX both measure 4. Lynn thinks these triangles must be congruent. Priya says she knows they might not be congruent. We want to construct two triangles with the given measurements that are not congruent and explain why triangles with 3 congruent parts aren't always necessarily congruent. Okay, so we're basically just proving that SSA works. So we want to construct some triangles that look a little bit different, which means I am going to draw in a thinner pen down here. I'm going to draw a straight line here as a base, and we'll call this the 6. I'm going to make what I think looks like a 30-degree angle, probably like here. And so I'll say this is 30 degrees. Now, our fourth side, so this is fourth side. Our third side of this is going to be 4 units long. So let's call this triangle, I'm going to label this one as ABC, and then I'll construct one for XYZ that actually looks different. So they said ABC was 30, so this is going to be A, and then B, and C. And now we want to make that next one XYZ. So I can do the same thing. I'll draw myself a fairly long base side here and call that 6. I'm going to draw myself like a 30-degree angle. I'll make it actually look just like my other one to start with and have my 30 degrees. But we're going to start our triangle on the other side here, and I'm going to just make a straight line. This would normally have been the 4, but we can also make a 4 going about like this way right here. I can make this be 4. And then what happens is, Miss Fountain picks a very large eraser on accident. Then I can still have a length of 4, but my X, Y, Z, and my A, B, C look very different. So we have 2 pairs of corresponding sides, and we have an angle, but just because, even though they're in the correct order and everything, I'm going 30 degrees, then 6, and then 4, 30 degrees, and then 6, and then 4, even though the order is right, 2 very different triangles. So, explain why. Oh, how can I put this in words? Okay. Technically, this happens when we have the shorter side opposite from the angle that they give us. So if our longer side is here at the bottom, our shorter side can actually either extend this way or this way. It's like an isosceles triangle that it could make. So if we drew it even on like this one here and started at that corner, I could make an isosceles triangle basically like this, where I say like that and this are the same length, and then it's not congruent. So when the shorter side is across from the given angle, it can be in two different positions. And that's my explanation for that one. So the last one we're doing here is question 3. This is Jada stating that the diagonal bisects those. Is she correct and explained? This is from the last homework assignment that we just looked at, which was lesson 9. So she is saying that it bisects these two angles, ZWX and ZYX, and she is correct. But how can we explain that? We are going to say, sorry, I'm going to erase those. We are going to say, yeah, we'll have to state the side thing. So triangle, I'm just going to use the order they gave me here, ZWX. Nope, that's not the triangle. It is ZWY. That looks like an X, it's a Y, is congruent to triangle XWY by side, since WY is congruent to WY. That's by the reflexive property, or because every segment is congruent to itself. Then we can say angles we're going to say that basically these two angles being split right here at the top and these two angles down here at the bottom correspond to each other, which means that it has to be the bisector. So we're going to state that the angles are congruent, and that'll be by CP/CTC. So angle Z, W, Y is congruent to angle XWY, and angle ZYW is congruent to angle XYW. Both of these are by CP/CTC, corresponding parts of congruent triangles are congruent. Therefore, WY must be the angle bisector. Oops. And there we go. So when I first filmed this video, I actually forgot to do the rest of homework assignment number, or I guess lesson number 11. I thought I did the whole thing, but I actually didn't see this page. I think I tried to switch pages on my tablet and I just didn't swipe enough or something like that. But yeah, so we're going to do questions 4, 5, and 7 here. There are 3 questions I did leave off of the original video, so if the edit between these chunks is a little choppy, or you watched the original video a little earlier and you were like, where are those videos? Or where are those questions in the video? Sorry about that, and here they are. But, I was trying to keep the video as short as I could, but it is a pretty long assignment for the weekend, so sorry I'm adding a little bit onto it. But this is the second part of the assignment here for lesson 11. So let's look at what we have here. So we want to select all true statements based on the diagram. So they're giving us this one here. This is looks like we have a trapezoid at the very least, probably an isosceles one, but we have A, B, C, D going around the outside and E here in the middle. So this says angle CBE is congruent to DAE. CBE, going from C down to B and up to E, that means this angle right here. And they're saying DAE, so CBE and DAE. I would say yes, that those would be congruent, but let's double check because they look congruent, but we want to make sure that we're able to actually prove something. So I might actually go through this diagram and see what I'm actually able to mark here. So I know I do have an isosceles triangle here in the middle, right here. So let's mark, I'm going to use red so it stands out a little bit more. We're going to mark our corners because those angles right there, so that's like DBA and CAB, those should be congruent because the isosceles triangle theorem. And then let's see, what else? Yeah, okay, so I do see that we have also in the middle here, we have a right angle. So that means that this entire thing is all going to be right angles because one right angle means there has to be another one here to make 180 degrees for this line. And if there's a right angle here, that means there's also going to be a right angle next to it to make a 180 degree angle for this line. So I am going to mark those in my red marker if we need to see them here. Actually, I'm just going to mark the one across from it because that's what I care about for this one. And we actually do have hypotenuse leg then on these triangles because these are right triangles. I have a hypotenuse and I have a leg piece here. And again, a right triangle with a hypotenuse and a leg. So I am going to be able to say that all pieces of that triangle are congruent, which means this angle and this one, which I think was actually that first option. It would also be this angle and this one. Basically, we would have CPCTC. So what I'm going to do is, since I know these two triangles are congruent, I'm actually just going to highlight them both. That way I don't have to mark a ton all over my graph, but I will color them in. That way I have something sort of telling me that these are going to be congruent to each other, at least so that my brain can keep track of it easier. Okay, so I think for this first one they said CBE and DAE. So yes, that is this angle here and this angle here. So agreed based on this diagram, since I'm going to have hypotenuse leg, then yes. Now B says CEB. So CEB, that's the right angle right here on the green triangle on the right. They're saying that's congruent to DEA. Yes, absolutely. Even just because these would be vertical angles with each other. But we already know that we're going to have hypotenuse leg for those triangles. So, yep. Now they're saying DA is congruent to CB. That is actually something they gave us with congruence marks here. So it's already marked. So we know that one is going to be true as well. Now they're saying segment DC is congruent to AB. That's saying this top side here and the bottom piece. And that is not necessarily true. So I am going to put a line through that. They're now saying DC is parallel to AB. That one is true as well because we have arrows on both of these, and that means that these are parallel to each other based on our diagram. So that is true. And then the sides, they are saying that DA is parallel to CB, and there is nothing that actually tells us those are true. So it is A, B, C, and E for this one. Now, question 5 here is about finding some angle measures. So let's read what we have, and then we'll mark on our diagram afterwards. WXYZ is a kite. Angle WXY has a measure of 94 degrees, and ZWX has a measure of 112. So let's put those in before we continue reading what they want us to find. So WXY, that is this over here on the right. This is 94 degrees. And ZWX, this one here, I'm going to put a line kind of all the way through it, just to mark that I'm talking about the whole thing, is 112. Now they want to find ZYW. So the one they're asking us to find is this down here at the point. They're asking us, what is this one? So we want to show all of our work. So on this kite, we know originally, excuse me, we're going to have side, side, side triangle congruence because we're given two sets of sides already. And that is based on our definition of a kite. It has two sides that are congruent next to each other, and then another pair of congruent sides. So the diagonal that runs between them and cuts it in half here is going to give it side, side, side triangle congruence. So that means that 94 here is going to correspond with this angle. So I can write that 94 here as well. That also means, oh, I meant to do that in a different color. That also means that this angle at the top, because these angles here will be congruent, since they're corresponding parts of congruent triangles are congruent, we can cut that 112 in half, which would be 56. So we're going to have 56 and 56 for each of those. Meaning now I know that this whole triangle on the left here, so WZY, this whole triangle should add up to 180. So I can say 180 minus the 94 and minus the 56. 94 and 56 are actually going to add up to 150. So 180 minus 150 should give us 30 degrees. So my answer for the measure of angle ZYW is 30 degrees. Okay. I just wanted to check my mental math there for a sec because wasn't entirely sure, but if you want to check me too, I'm going to actually just run through this here. So I said in my head, for me at least, 90 and 50 would make 140, but this 4 and this 6 would make another 10, so that's where we would get 150 from. So these two together were 150. Okay, now we are skipping question 6. But we are going to do question 7 here, and this is just which sequence of rigid motions would take DEF, so DEF is the triangle on the right, over to BAC, so right here. So D needs to correspond with B. So we're going to translate using directed line segment EA. That is going to take E onto A. So then we would rotate using A as the center. I'm going to actually just draw over this so that I can imagine it myself. And I'm going to use some red lines here because red will stand out better than blue or the black marker I normally use. Okay. So what they're saying is take this and translate E so it lands on A. It would look something like that. Then we want to rotate using A as the center so that D prime is going to coincide with C. Well, I see a problem here because D prime would be this little chunk, and I cannot rotate that so it lands on C. And then reflect across AC. Also, D is not going to correspond with C. D should be corresponding with B. So we're going to say for this one, nope, not going to work. We then have DEF using directed line segment EA. So that part, okay. Then rotating using A so that D prime coincides with C and reflect across AB. Again, has that error of D prime coinciding with C is not going to work. Yeah, I was second guessing myself there for a minute. Our bottom two options are going to have D prime coincide with B. And that is actually what should be the case. So if we look here, D should be coinciding with B. So they would say, hey, take this, rotate it. So I'm going to rotate it, but they're saying rotate it this way around A so that these bottom pieces then match up. And you would have it like this, and then reflect across. That seems much better because then F would be taken on to C. So D, E, and F would match up with B, A, and C respectively. Or, yeah. So D, E, F, translate it, rotate using A as the center, D prime coincides with B, reflect across line AC is incorrect here though, because once we're here, we want to reflect across line AB. So if I reflect across AC, my triangle is going to end up like here, and that's not what we want. So it's not going to be option C. This one's not going to work for us. We want to reflect across line AB. This needs to coincide with B. D is our solution here. So again, sorry I missed a couple questions here. I didn't mean to skip out on those. Just honestly did not see that. And since I'm not using a physical packet, it didn't register with my brain that I had an additional page to do. So hopefully that helped with understanding these questions. And thank you for joining me for this assignment.